Okay, in this lesson we're going to learn about a different way of measuring angles. There's two ways to measure angles. First is in degrees, and that's what you're most familiar with. And the second is something called radian measure. And radian measure is just another way of measuring an angle. Kind of like you can measure a distance in feet, inches, yards, meters. Angles can be measured in radians or degrees. Okay? So what is a radian? A radian is defined as the measure of a central angle, and from geometry we know central angles are angles whose vertex is at the center of the circle. So it's the measure of a central angle. It's what's the measurement of that angle? It's the measure of the angle that intercepts an arc equal in length to the radius of the circle. So here's the radius of the circle. Well, if you took this radius and you measure what that length was, and then you bent that radius onto the circle, this distance from here to here is called a radian. Okay? And we know that from geometry, if this was 20 degrees, then this angle here would be 20 degrees. So in this case, if this is a radius, this is a radius as well. So this is what they call a radian. Okay? Now, question is, how many radians are there in a circle, and what is the conversion rate from radians to degrees? Because we know there's 360 degrees in a circle. The question is, how many radian measurements is that? So, first of all, let's look. What is the circumference of a circle? This is probably the formula that most of you mix up either circumference or area. But the circumference equals 2 times pi times the radius. Okay. Now, how many radians are there in a circle? Well, we know a radian is measured by the radius. So in order to find how many radians, you would take 2 pi r, which is the circumference, divide that by how many radiuses there are as you measure it around, and we cancel out that because we're dividing by r, so the r's cancel, which gets you 2 pi radians. So there are 2 pi radians in a circle. Now, if you consider pi approximately 3.14, 2 times 3.14 gets you 6.28. So the measure around the circle in radians is approximately 6.28. Now let's actually show that that's actually the case. Let's start at this point, and we're going to come all the way around this circle. Okay? And we're going to find out how many radians there really are. So what we're going to do here is I'm going to take the ruler, I'm going to measure off the radius. Okay? And I've already done that here, so let me do it again. Okay? So from here to here is another radius. Okay? Let me measure that off again. So we're going to have another one. So from here to here is also another radius. Okay. Measure that off again. From here to here is also a radius. Let's measure that again. There. From here to here is a radius. Let's measure it again. So right here, from here to here is a radius. Well, how many radiuses are there? This is 1, 2, 3, 4, 5, 6. But then what's this little bit right there? That little bit there is the 0.28. Okay? So you can see there's approximately 6.28 radians, or that's 2 pi radians in a circle. There's 2 pi radians all the way around the circle. Now, let's figure out what the ratio from radians to degrees is. Well, ratio is just going to be a fraction here. So the radians, we know there's 2 pi of them in a circle, and we know there's 360 degrees in a circle. So if we reduce that, 2 goes into 360, 180 times. So your ratio is pi over 180. Okay. Which means for every pi radians, there are 180 degrees in a circle. So what we're going to do is we're going to use this conversion rate to convert from degrees to radians, radians back to degrees. Okay? And that's what we'll be doing in the following exercises here.